I am Anil Kumar. Welcome to my series on System of Linear Equations. We have 10 test questions, word problems, which will be solved using the elimination method. You can always solve them with substitution method also. Question number 1 is, white vinegar is a solution of acetic acid in water. There are two strengths of white vinegar, a 5% solution and a 10% solution. How many milliliters of each solution must be mixed to make 60 milliliter of 9% acetic acid solution? You can always pause the video and answer these questions. Here is my way of doing it. I prefer to illustrate the given information of a mixture type problem as shown here. Now this method is very useful and can be adopted to any mixture problem. So you have two which are being mixed to provide what is required, correct? The ones which we have are solutions which are 5%. So when I say 5%, it means 0.05 in decimals, right? So that is the strength. And let us say the quantity is X, right? For the other one, it is 10%. So 10% I'll write as 0.10. So percent being converted to decimals, right? Let us say Y of this is being mixed together. So what you get here is a quantity which is X plus Y, right? But we are given that, in fact, we need to find how many milliliters of each, that is X and Y, must be mixed to make 60 milliliters. So we want this to be 60 milliliters of 9%. 9% is 0.09, right? So whenever we have 5%, right? So we have 5%. It means we have to write 5 over 100. So that is 0.05, which I am writing here. So I hope that is clear, right? Now let us see how to form equations from this given information. So that is very important to understand. Now one equation clearly is that the total amount X plus Y is 60, right? So we get one equation which is X plus Y equals to 60. Since we want to make 60 milliliters of total. The second one we can get using the strengths. 5% of X, 10% of Y will give us 9% of 60 ml, right? So 5% of X can be written as 0.05 of X plus 0.10 of Y will give us 90% of 60 milliliters, right? So 90% is 0.90 of 60 ml, right? So we know X and Y when added gives you 60 ml. So that is how you get your equations. Now let's number these equations. Let's call this first equation, right? And this one as our second equation. Now how can we eliminate one of these variables? Well, if I multiply my first equation by 0.10, then we get the same coefficient for Y, right? And we can eliminate, right? So let's do that. So multiplying the first equation by 0.10 gives us 0.10x plus 0.10y, which should be equal to 60 times 0.10, right? Now 0.9 times 60 is 5.4. Just multiply. 5 times 9 times 6 is 54. I can write this as 5.4 and I can write this as 6.0. Clear? So we get these two equations. Let's call this equation as equation number 3. Now we can eliminate Y by taking away equation number 2 from 3. So if you do that, then 0.10 take away, let's write 0.10x minus 0.05x. These two quantities cancel, gives you 6.0 minus 5.4. Clear? So that is how you get your equation. Now we can always solve this equation and find our answer, right? So what we get here is 0.10 minus 0.05. Let's take it on this side. Gives us 0.05x is equal to 6.0 minus 5.4 is 1.6, right? Or 0.6. So you have to borrow from 1. This you get 5 minus 5 is 0, 0.6. So we get x equals to 0.6 divided by 0.05, or you can say 60 divided by 5, which is 12. So we get the value of x as 12. So we know this 5% of acetic acid is 12 milliliters, right? Now how much is y? So we can use this value of 12 in our equation number 1 and then figure out that y should be equal to 60 minus x, which is 60 minus 12, or is equals to 48 milliliters. Clear? So we can now write down our answer, which is we need 48 milliliters of y and 12 milliliters of x. So our answer here is we have 12 milliliters of 5% and 48 milliliters of 10% solution. Is that clear to you? So that is how it can be solved. So I hope all the steps are clear. Let's move on and take the second question now. Question number 2. The area of a rectangle reduces by 160 meters square if its length is increased by 5 meters and width is reduced by 4 meters. However, if the length is decreased by 10 meters and width is increased by 2 meters, then the area is decreased by 100 meters square. Find the dimensions of the rectangle. So let's begin with the one rectangle with, let us say that the length is L and width is W, right? So in that case, the area is equal to length times width, right? So that is given to us. Now what we are saying here is that area of the rectangle reduces by 160 meters square if length is increased by 5. So we get an equation, length increased by 5 and width reduced by 4. Width reduced by 4. Area of the rectangle is reduced by 160. So it was earlier length into width, right? It was earlier length into width. Take away 160. Does it make sense? So that becomes the first equation for you, right? You can always rearrange this equation, right? So we can just multiply and open this. So we get length times width plus 5 times width minus 4 times length minus 20 equals to length times width minus 160, right? So in this equation, length times widths cancel. What you're left with is 5 times width minus 4 times length equals 2. Taking minus 20 on the other side gives us minus 160 plus 20, or minus 140. So that becomes one of your equations. So we'll call this as our equation number 1. Second condition is, however, if the length is decreased by 10, that means length minus 10, and width is increased by 2, width plus 2, the area decreases by 100 meters square. So area becomes minus 100. So it is length width minus 100, right? So that's what you get. Now we can again expand it. Let me multiply with L both the terms first. So we get length width plus 2L minus 10W minus 20 equals to length width minus 100, right? So length width and length width, that product cancels. We get 2L minus 10W equals to, taking minus 120 to the right side, we get minus 80. Is that clear to you? So we did minus 100 plus 20 to get the second equation. So now we have these two equations, equation 1 and equation 2. How do we eliminate one of these variables? We need to find the dimensions. So what we can do here is, let us say we want to eliminate the length part, right? That is easier. We can multiply 2 by 2, right? So what we will do here is we'll multiply our equation number 2 by 2 and rewrite. So if I multiply this by 2, I get 4L plus minus 20W. So when I multiply this by 2, we get 4L minus 20W equals to minus 160. We already have the other equation, which is minus 4L plus 5W equals to minus 140. Now we can eliminate L by adding them up, right? So if you add them up, you get minus 15W equals to 300, correct? So the width basically is 300 divided by 15, correct? Which is equal to 20. So width is 20 for us. We can now find the length using width as 20 in any one of our equations, correct? So let's sub W equals to 20 in, let us say, equation number 2. So substituting 20 in equation number 2, we get 2 times length minus 10 times 20 equals to minus 80, or 2 times length equals to minus 80. So we get minus 80, and that is 200, right? So plus 200. So we get 2 times length equals to, when you take away 80 from this, you get 120. So the length is 120 by 2, which is 60. The units are in meters, right? So units are in meters. So we get our answer that length equals to 60 meters and width equals to 20 meters. Is that clear to you? So that is how we can actually solve such a question. So I hope the steps are absolutely clear. Now let's take question number 3. Question number 3. The age of father is twice the sum of ages of his 2 children. After 20 years, his age will be equal to sum of the ages of his children. Find the age of father. So we can start with let statement. We can say let father's age be F and sum of children's age be, let us say, C, right? So C is the sum of ages. Does it make sense to you, right? So from the first condition, which is age of father is twice the sum of ages, that means we get one equation, and which is age of father is twice C, correct? C is the sum of ages of 2 children. Okay. Now, the scenario is after 20 years. What happens after 20 years? After 20 years, father's age will be F plus 20, right? And children? Children's sum we have to take, right? So earlier it was C. Each child will increase by 20 years, right? So that becomes after 20 years. Now it says After 20 years, his age will be equal to the sum of the ages, right? So after 20 years, we are saying f plus 20 is equal to c plus 20 plus 20, right? So we get f plus 20, 20 we can take on the other side, is equals to c plus 20, right? So 40 minus 20. Is that clear to you? So we get two equations, which is like c plus 40, right? So when you take away 20 from 40, you get 20. So we get our equation number 1 and equation number 2. Now, we are actually using the method of elimination to find f. So how do we eliminate c? To eliminate c, I will this time multiply the second equation by 2. So when I multiply the second equation by 2, I get 2f equals to 2c plus 40. Is that clear? So we get our equation number 3. Now, if I do equation number 3 minus equation number 1, right? So we are now taking away from this equation the first equation to get the father's age, since we want to only find the age of father, right? You could find by eliminating f first, child's age, and then multiply by 2. That is also correct. Is that okay? But I have taken it the other way, slightly more complicated. Right, so when you take away the difference, you get father's age will be 2c, 2c cancel, you are left with 40, right? So that is your answer. Is that okay? So therefore, father's present age is 40 years. Correct? Alternately, you could have found sum of children's age first, right? You could have done that by eliminating by doing 1 minus 2, right? Let me do that. Alternate. Alternately, we could have done equation 1, take away equation 2. In that case, we get 0 equals to father age cancel. 2c minus c is c minus 20, right? Or c is equals to 20. And then we can place c20 into 1. Then we can sub c equals to 20 in 1, right? So we get f equals to 2 times 20, which is 40. So that is also correct, right? So that is how you could do it. Let's move on and take question number 4. Question number 4. 8 men and 12 boys can finish the piece of work in 10 days, while 6 men and 8 boys can finish it in 14 days. Find the time taken by 1 man alone to complete the job. So we need to find time taken by 1 man. So let it be x days. So x days for a person alone, right? Or we can say y days for 1 boy, right? To complete the job. Right, so these are the variables defined. Now in such questions, we really need to find the rate, right? So what is the rate of work? So we need to find the rate. That is kind of very important. Rate means per day. That is what it means. So when we are saying the total job is completed in X days, so in 1 day how much? So the rate for a man is basically 1 over X, right? And rate for a boy will basically be 1 over Y. So this should be understood very clearly, right? So that helps us to get the equation. 8 men and 12 boys can finish a piece of work in 10 days. So in 1 day how much? 1/10, right? So from the first statement, we get our equation as 8 men, 1 day work. So 8 over X plus 12 over Y is equal to 1 over 10. So we get our equation for 1 day work. So in 1 day, 1/10 of the work is done, right? 8 men will do 8 times 1 over 6 and 12 boys will do 12 times 1 over Y of the work. And we get our equation number 1. Do you see that part, right? So that is how you get this equation. Second equation is very similar to this. While 6 men and 8 boys, so 6 men and 8 boys can do it in 14 days. So 1 over 14. Is that clear to you? So we get two equations. Now, how do we eliminate? We need x, we want to eliminate y. Let's go for multiplication. So what we will do here is we'll multiply the first equation by, let's say 2. It becomes 24 and the second by 3. Is that clear to you? So if I multiply the first equation by 2, I get 16 over x plus 24 over y equals to 2 over 10. The second equation by 3 gives me 18 over x plus 24 over y equals to 3 over 40. Is that clear to you? Now this is a very critical way of doing it, right? And very important to understand. So we times each equation by different numbers to get the same coefficients for 1 over y. Correct? So we get second set of equations. Let's call them as equation number 3 and 4. And now what we can do is we can take away one from the other. So if I do equation 4 minus equation 3, then what do I get? So this minus this. So we 18 minus 16 over x, these cancel, and here we get 3 over 14 minus 2 over 10. So that is 2 over x equals 2. Let's cross multiply, right? So we get 30 minus 28 over 140, right? Which is 2 over 140. So that gives you the value of x, just cross multiply, equals to 140. Do you see that part? So we could easily solve this equation using ratios and cross multiplication. So idea is to solve this by ratio and then cross multiplication. So that's a very important strategy. So we can now say one man can complete the job in 140 days. Right? Now let's take question number 5. Question number 5 is, Milton and Brampton are 80 kilometers apart on a highway 401. A car M starts from Milton and another car B starts from Brampton at the same time. If they move in the same direction, they meet in 8 hours. And if they move in opposite direction, they meet in 1 hour 20 minutes. Find the speed of each car. Well, let's sketch the scenario. So let's say that's the highway. Milton and Brampton. Let's say this is Milton and this is Brampton. And they are given to be 80 kilometers apart. Okay. Now if a car M starts from Milton and another at B starts at Brampton at the same time, they move in the same direction, they meet 8 hours. Okay, so that means if one car starts from here, so it goes much faster, right? So, and they meet at the same time. These are the two distances covered, right? Okay. So this time t is given to us as 8 hours. Okay, let's find the equation for this. Let's define our variables. We need to find speed of car. So let's say let speed of car be, let's say M and B respectively. I mean M from Milton, B for Brampton. Is it okay? Right. Now, how much is the distance traveled in 8 hours? So for Milton car, it will cover distance will be how much? Let's see the distance now. So for Milton car, which moves at m speed, in 8 hours, it will be 8m, right? And for Brampton car will be 8b. So that is the distance. So this is the distance. So distance covered will be by each in 8 hours will be what? Will be 8 times the speed, which is m, and 8 times b respectively. Is that correct? Since distance is speed into time, right? So remember this triangle. So we know distance is speed into time. So we know time is 8 hours, speed is m and b, so 8m and 8b. Now from here clearly you get one equation, and what is that equation? The equation which you get is that the difference between the two, that is 8m minus 8b, is 80 kilometers. Is that clear to you? Very interesting equation, right? So no fractions involved, very simple. Distance covered with the faster car will be 8m, and with the slower car will be 8b, and the faster car covers 80 kilometers more, right? So that is how you get your right equation. The second one, if they are traveling in the opposite direction. Now let's see the second scenario. So in the second scenario, this is your Milton car, this is Brampton car. They are traveling in the directions opposite. They meet somewhere here. Okay. Now, in that case, they meet in 1 hour 20 minutes. So, okay, 1 hour 20 minutes is what? Means 1 hour 20 over 60, right? Which is 1 hour 2 over 3. Or you can write this as 1 over 3, right? So that can be simplified and written as 4 over 3 hours. Is that clear? So now the time is 4 over 3 hours. So 1 hour 20 minutes is basically 4 over 3 hours, right? So the distance covered is how much this time? It will be, this distance is 4 over 3 of m, and this is 4 over 3 of b, right? That is the distance covered. Sum of this distance is 80, because the total is 80, right? So we get 4 over 3m plus 4 over 3b equals to 80. So we get our second equation. Is that clear to you? Right? 4 over 3m plus 4 over 3b equals to 80. Now if I multiply by 3 over 4, the second equation, right? So we could write this as m plus b equals to 80 times 3 over 4. Or that goes 20, right? So we get 2 times 360. Is that clear? 3/4 of 80. So we get second equation modified as 3. So we just multiplied all the terms by 3 over 4. We got this equation, right? In the first equation, I could divide by 8. Right, so this could be written as, let me rewrite, m minus b equals to, dividing by 8 gives you 10. We'll call this as our equation number 4. So we kind of simplified both equation 1 and 2. Dividing the first equation by 8 gave us m minus b equals to 10. Multiplying the second equation by, so we divided this by 8 and we times this by 3 over 4. Do you see that? To get simplified equation. Now we can eliminate and find the answer. So let's do it. So if I do equation 4 plus 3, so if I add these two equations, 4 m minus b equals to 10 and m plus b equals to 60, if I add them, I get 2m equals to 60 plus 10, right, which is 70. So m is equals to 70 over 2, which is 35 kilometers per hour, right? And if I take away one from the other, right, so if I take away, or now we can write, since we got one value, m, we can find what b is. So b is equals to 35, we substitute b here, right, minus 10, which is 25, correct? So from here we can find what b is. So we know we can find b from here or on the other place, either way. So we get our answer as b equals to 25. So the speed of the car will be the one from Milton. So speed m is equals to 35 kilometers per hour and b is 25 kilometers per hour. Is that clear to you? So that is how we are going to solve it. So I'd like you to have a good look at it. So in this small space, actually, I have combined many steps, but I hope you understand how we have solved it. So initially, we got our equation that the difference in the distance traveled is 80. In the second, the sum of distance is 80, right? That helped us to find the solution of the given equation. Here is question number 6, which relates distance, speed, and time. A man travels 600 kilometers, partly by train and partly by car. It takes 8 hours and 40 minutes if he travels 320 kilometers by train and the rest by car. It would take 30 minutes more if he travels 200 kilometers by train and the rest by car. Find the speed of train and car. Now, these types of questions are very important from test point of view, and they require a lot of calculations. So we will at length understand how to solve such questions. Okay, few things which you need to remember is how to relate distance, speed, and time. So that triangle which I am making here relates distance, speed, and time. Distance, let's say d, is equal to speed into time, right? Or time is distance over speed. Now, based on the question, let us make a sketch to understand how to solve it and how to write the equations. A man travels 600 kilometers, so let's say, so that is a distance of 600 kilometers, partly by train and partly by car. It takes 8 hours and 40 minutes if he travels 320 kilometers by train, so slightly more than half, let's say this much, right? So we are saying that distance covered by total is 600, okay, out of which 320 is by train, so the balance is how much? Just take away 320 from 600, so we get 0. 10 take away 2 is 8, 5 take away 3 is 2, 280. Now, for all this, time taken is 8 hours and 40 minutes. So time t for us is 8 hours. So 8 is hours. Now 40 is in minutes. We need to convert them into 1 unit, right? So as you prefer, you could do it in hours or in minutes. I prefer to do it in hours, and we are going to use fractions. See how. 8 hours and 40 minutes. 40 minutes means what? 40 in hours is 40 over 60, right? So that gives you time in hours. Is that clear to you, right? So 8 whole 40 over 60, right? Now if you simplify this, you get 8 wholes. 0 and 0 cancel, divided by 2, 2 over 3. 2 over 3, right? Now, we can convert that to improper fractions. 8 times 3 is 24, plus 2, 26 over 3. So that is how you need to convert. This is kind of very important step. And the time now, we have it in hours. Clear? So total time to travel the whole distance is 26 over 3. Now time is distance over speed. So let us say that the speed of train is capital T. So time taken for train is how much? So the time taken by train should be, let's write this equation here. So this time for 320 kilometers should be, distance is 320, right? 320 divided by the speed of train, right? So let me call the speed of train as S of t, right? Speed of train. Is that clear to you? Plus distance of 280 by car, right? So that is speed of car. And total time, this is the time for each, right? So total time is 26/3. Is that clear? So that is how you can actually form your equation. Perfect. Now we know exactly how to make equation from the given situation. So second equation should be what? Let me write down the second equation in a different ink. We now know that it would take 30 minutes more if he travels 200 kilometers by train and the rest by car. So in the second case, let's make it here. In this case, says if he travels 200 kilometers, slightly less than, so we have 200 by train this time, and out of 600, 400 by car. Now, in this case, we need to find time. Time is 30 minutes more than 26/3 hours, right? 30 minutes means half more, correct? Okay. So in this case, let's find time. So time, this time is equal to 26/3 was last time's time plus half an hour. 30 minutes means half an hour. Is that clear to you? Right. So that gives you denominator of 6, right? So, and when you multiply, you get 52, 26 double, right, plus 3. Correct? So now you get your time as 55/6 hours. So that is the time calculation. So in this question, time calculation and working with fractions is very important, which we are focusing on. Now, let's calculate time for train and car. So time for train will be this time 200 divided by the speed of train, which remains same, right, plus 400 divided by speed of car, and total time is 55/6. You see that? So we get our second equation. So we have two equations here and two unknowns. Speed of train and speed of car are the two things which we need to figure out. Now, how do we eliminate one of these? So let's decide to eliminate the speed of train, right? In that case, we need to see what to multiply by so that we get the same common coefficient for the speed of time. Okay, so we could do this by doing ladder division method. See, I'll teach you this method to find common denominator. So we have talked about it earlier. Many of you must be knowing about it. We want a common multiple for 200 and 320, right? So I could divide both by 10, so I get 20, and 32. Both I can divide by 4, I get 5, right? And 8. Now we don't have anything common to take away. So the lowest common denominator. So this calculation is for lowest common denominator, correct? So we get here that the lowest common factor, you can say, in our case, will be product of these, right? So which is 10 times, 4 times, 5 times, 8, correct? Now 4 times 5 is 20, 20 times 8 is 116, right? And then 1600, right? So we get this as equal to 1600, right? So that becomes the lowest common factor. Now the idea is to multiply these equations so that 200 becomes 1600 and 320 also becomes 1600. Clear? Okay. Let's see what is the factor by which we can multiply them. So looking into this, 200 is an easy calculation. Let me show you how. 4 times 5 is 20, 20 times 100 is 10 is 200. So we are left with 8. So we are going to multiply this equation by 8, right? The other equation we need to multiply by what? 320, right? So 8 times 4 is 32 and 10, 320 multiplied by 5. So we have to multiply this by 5 to get 1600 as a coefficient for speed of time. Is that clear to you? So what we are doing here is that multiply equation 2 by 8, equation 1 by 5, right? Then what we get here is same coefficient, and then we take away. Is that okay? That is the step. Okay, so let's do it. So now, when you multiply this by 5, what you get here is 1600 over speed of train plus 5 times 280, 0. 8 times 540, 0, 4. You get 1400 over speed of car equals to 5 times 6, 33. So 130 divided by 3. Clear? So that is what you get in this case. Here, when you multiply by 8, you do get 1600 over speed of train plus 8 times 4 is 32. 100 over speed of car equals to 8 times 5, 40, 44 over 6. Clear? So this is after multiplying by 8. Now we have to take away from this equation that equation. Correct? What do we get? 1600 over st, which is speed of train, cancels. And here you get 3200 over speed of car minus 1400 speed of car equals to 440 over 6 minus 130 over 3. Clear? Right? Now you can take the common denominator, which is speed of car. And when you do 3200 minus 1400, what do you get? 12 take away 4 is 8. 2 take away 1 is 1. On this side, now what we need to do is we need to multiply this by 2, right? So what we get here, common denominator 6, 440 minus 2 times this is 260. Correct? So let's do this math now. So what we get here is 1800 over speed of car equals 2. So when you take 260 away from 440, we get 0. 14 take away 6 is 8. 3 take away 2 is 1 over 6. Right? Now you can cross multiply. Speed of car is equal to 1800 times 6 over 180. Correct? Which is clearly, this is 10 times 6, 60. So the values are taken for easy calculations. Calculator may not be allowed for this question sometimes. So we get a speed of car as 60, right? Now, let's figure out what is the speed of train. Now, we can substitute this value of 60 in one of our equations. So we can sub this in equation 2, right? So let's do sub in equation 2, right? There's less space, so I'm just squeezing it in. So we are writing 60 here for speed of car. We get 200 over speed of train plus 400 over 60 equals to 55 over 6. Clear? Now, let us try to simplify this. So what we have here is 200 divided by the speed of train is equal to 55. We have 60 here, right? So 55 over 6 minus 400 over 60, right? Now to make it 60, we'll multiply with 0 in both numerator and denominator. So we get a common term here, right? So now it's easier to simplify. 550 minus 400 is 150, right? So what we get here is 150 over 60 is 200 over speed of train. Is that clear to you? So see how we simplify, taking a common denominator, and now we can cross multiply and get our answer. Is that clear to you? Right. So let's move towards the left side, and we can now write from here. We'll move towards this side, and then we write speed of train, cross multiply them. Correct. So we can write speed of train is equal to 200 times, so when you go to, so 60 divided by 150. Clear? So you can now simplify, cancelling zeros, and both can be divided by 3 and 5. Correct? So by 3 we get 2, and 3 times 5, and 5 goes 40 times. 40 times 2 is 80. Is that clear to you? Right? So we get our answer, and that is the speed of car is 60 kilometers per hour, and speed of train, which you say ST, is 80 kilometers per hour. Is that clear to you? Correct? So that is how such questions can be solved. I would like your attention on this, since we are working with fractions, which at times is difficult for many students. See how we use the concept of common denominator most of the places. We did not really simplify to the lowest terms, but we looked for common denominators, and that helps, right? That helps. So that is how we are going to solve similar questions. I'll provide you with a link on many such examples relating distance, speed, and time, as this is a critical question for many test papers. Now here is question number 7. Peter rows 12 kilometers downstream in 3 hours. On the return trip, it takes him 4 hours to travel 8 kilometers. Determine the average rowing speed and the speed of the current. Okay, so let's say that's the river flowing, right? And we are saying that the speed of the current is SC, right? So that is always in one direction. Now we have two scenarios. One of the scenarios is going down 12 kilometers, right? So during this time, let's say the rowing speed is constant, we say rowing speed is SR. Now, this is a distance of 12 kilometers, and time is 3 hours. So that gives you the equation which we are looking for, distance, speed, and time, right? So we are always looking into this triangle to relate distance, speed, and time. So the distance of 12 kilometers is equal to speed into time. Now what is the speed? Now these two speeds, when you are doing in the same direction, add up. So speed is speed of rowing plus speed of the current, and the time is 3 hours. Clear? So that becomes your equation. You can divide by 3 and get it in simpler form. So 4 is speed of rowing plus speed of current. Clear? We'll call this as our equation number 1. Now, let's look into the second scenario when Peter is returning back. So in that, he is able to do 8 kilometers in 4 hours. So returning back, let's say 8 kilometers, time is 4 hours. That's it. Now in this case, the speeds are going to be opposing one another. Is that clear? So in this case, what we have is distance of 8 kilometers, and speed is going to be the difference of the two. Speed of rowing minus speed of current, and time taken is 4 hours. You can again simplify. We get 2 equals to speed of rowing minus speed of current. So we get our second equation. Correct? Two equations, two unknowns, we can easily eliminate by adding them up. So we'll add equation 1 and equation 2. When you add, you get 6 equals 2. 2 times speed of rowing, right? So we get 6 divided by 2, which is 3 as speed of rowing. Clear? So once you get one of the values, you can always substitute that and get the other value. So that is the strategy, correct? So now we know that speed of rowing is equals to 3 kilometers per hour. We'll substitute this in one of our equations to find speed of current. So we can use equation 1. So we'll sub in 1. So we know speed of current will be equal to 4 minus speed of rowing, which is 4 minus 3, and that gives you the value as 1. So we get speed of current equals to 1 kilometer per hour. Is that clear to you? Right. So we get both our answers, and the answers are speed of rowing is 3 kilometers per hour and speed of current is 1 kilometer per hour. Clear? So that is how we are going to solve it. Now let's take the next question. The sum of numerator and denominator of a fraction is 4 more than twice the numerator. If 3 is added to each of the numerator and denominator, their ratio becomes 2:3. Find the fraction. So let the fraction be what? Let's say numerator divided by denominator. Let's say n and d. So numerator divide by denominator. Now, let's try to write down the equation. It says sum of numerator and denominator, that is numerator plus denominator, is 4 more than twice the numerator. So we'll do 2 times numerator plus 4. Okay, so let's reorganize. We can always write this as bringing 4 to this side, minus 4 equals to 2n minus n minus d, or minus 4 equals to n minus d. So that becomes our equation number 1. Now let's look into the second condition and find the second equation. If 3 is added to each numerator and denominator, that means numerator plus 3, denominator plus 3, their ratio becomes 2:3. Clear? So we get our equation. Now we'll cross multiply and get the equation. So 3 times numerator plus 3 equals to 2 times denominator plus 3. 3n plus 9 equals to 2d plus 6. Again, let's bring them together. We get 3n minus 2d equals to 6 minus 9. So we have 3n minus 2d equals to minus 3. So that becomes our second equation. Now how do we eliminate? Well, to eliminate, we can multiply equation 1 by 2. Right. So what we will do now is we have to make the same coefficient. So we'll multiply this equation by 2. So we get 2d minus both places. So when you multiply this by 2, you get minus 8 equals to 2n minus 2d. And we'll call this as our equation number 3. Clear? Now we have minus 2d and minus 2d we can take away. So we will do equation 2 take away equation 3. So when you take away from 3 and 2n, you get n minus 2d 0. And from here we get minus 3, take away minus 8. So n is basically minus 3 plus 8 or 5. So we get the value of numerator as 5. Now we can use one of our equations and find the denominator. So we'll sub this, sub n equals to 5 in, let's say, equation 1. So if I write 5 here, I get minus 4 equals to 5 minus d. So it becomes d equals to 5, and then 4 comes this side, becomes 9, right? So D is 9. So now we know that numerator is 5 and denominator is 9. Find the fraction. So our answer here is, fraction is what? Fraction is 5 over 9. Clear? So that is how we are going to solve this question. Let's move on and take the next question now. This is also number based. A number consists of 2 digits. When the number is divided by the sum of its digits, the quotient is 7. If 27 is subtracted from the number, the digits interchange their places. Find the number, right? So this is number. Okay. So let's say that the number is PQ. So we are taking number as, let's say, P times, that is our number. We need to find what is P and what is Q. These are the 2 digits, right? This is ones place, this is tens place. When the number is divided by the sum of its digits, the quotient is 7. How do we write this equation? When the number is divided by sum of its quotients, sum of its digits, quotient is 7. So the number is what? Number is 10 times P plus Q. That is the number, right? Divided by sum P plus Q. The quotient is 7. Is that clear to you? This is very important to understand, okay? Now, we can cross multiply. So we get 10P plus Q equals to 7P plus 7Q. Bring them together. So left side, okay? 10P minus 7P. And we have plus Q minus 7Q equals to 0. So we have 10 minus 7 is 3P, and Q is minus 6Q equals to 0. Okay. So we get one of our equations. Second one, if 27 is subtracted from the number, the digits interchange. So the number is 10P plus Q minus 27. So that is 27 subtracted from the number. Digits interchange, so it becomes QP, right? So it becomes 10Q plus P. Does it make sense to you? Right? So again, let's bring them to one side. We get 10P minus P plus Q minus 10Q equals to 27. Okay. Now, so we get 9P, and as far as Q is concerned, minus 9Q equals to 27. We can divide by 9, so we get P minus Q equals to 3. Okay. Here, we could divide by 3, right? So we get P minus 2Q equals to 0. So we'll call this as our second equation and this one as our first equation. Clear? Now we can eliminate P or Q. Well, let's eliminate P by taking away, right? So we'll do equation 2, take away equation 1. So P and P cancels and we get Q equals to 3. Clear? So we get Q equals to 3. Now when Q is 3, we can substitute this value and find what P is. So P is equal to 3 plus Q, which is 3 plus 3, which is 6. Correct? So we get our answer. So the answer is that the number is 63, right? So the answer is 63. Clear? So P and Q, so the number is 63. So that is how you're going to do it. So I hope that makes sense. Now let's move on and take the last question in our series of systems of equations. Question number 10. A pipe can fill a tank in 1.5 hours, and another pipe connected to the same tank can empty the tank in 4/5 hours. In how much time will the tank be 1/4 full if both pipes are turned on at the same time? So let's try to understand the situation. So we have a tank here and we have one outlet. So that is the outlet. And we have one inlet here. Okay. We are looking for a situation to fill in quarter of the tank. We are given both the rates. So for the whole tank, it takes time to fill as we'll write time to fill as 1.5 hour, which is 3/2 hours, correct? Now time to empty, let's say E, is 4/5 of an hour, which is 9/5 hours, right? Now, when we say empty, we'll use a negative sign. So in how much time will the tank be 1/4 full? So let that time be T. So in time capital T, tank is 1/4 full. Correct? So that is the condition given to us. Now how do we solve such questions? Whenever you have such questions which are related to rate, right? So the rate here is 3/2 per hour, right? If T is the total time taken, then the equation becomes total time divided by the time taken to empty the whole tank, which is 3/2. Since this is to empty, that one will be negative. It works for the same time T and get 9/5, and the result is 1/4 of the whole. Correct? So that is how you get your equation, right? And now we need to simplify this. So you can write this as 2/3T minus 5/9T equals to 1/4. So let's make common denominators. We need to multiply this by 3, right, to get it. So 3 times 2 is 6. 6T minus 5T/9 equals to 1/4. So that is T/9 equals to 1/4, or that gives you the time as 9/4, right? So now you can divide this 9 by 4. So 2 hours full and 1/4, right? So that many hours. It will be quarter full. Is that clear to you? So that is how you are going to answer this particular question. So in hours, 2.25 hour, or you could say quarter of 15 minutes. That is, so 2 hours and 15 minutes. So that much of time it will be quarter full. So with this, we come to an end of our set of 10 questions based on linear systems. All these questions were solved using elimination method. Well, for most of them, elimination method was a preferred method, but for some, you could always use substitution. I hope you've understood all these steps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.